Welcome to Robraintics, where we discuss recent research advancements in the field of neuroscience and robotics. Welcome back to Robraintics. We're looking at a paper today called Diffusion Policy, Visuomotor Policy Learning via Action Diffusion.
Oh, yeah, this one is interesting.
It's by Cheng Shi and his team, published in the International Journal of Robotics Research. So this paper, it's kind of a big deal.
Definitely a big deal.
It's introducing this, totally new way of thinking about how robots can learn.
Yeah.
Especially for those tasks where they have to, see and act in the real world at the same time.
Visuomotor policies, as they're called.
Yeah, exactly. Visuomotor policies.
So traditionally, we've tried to get robots to learn by basically, directly mapping what they see to very specific actions.
Oh, okay. So kind of like if you were giving them a super, super detailed instruction manual for every possible scenario they could encounter.
Yeah, that's a good way to think about it.
Okay.
The problem is that the real world is messy.
Right.
And there are a zillion different ways to achieve the same goal. You think about just a simple task like making a cup of coffee.
Yeah.
Right? There are so many variations. What kind of coffee maker you're using, what mug, even how you pour the milk.
Yeah, totally. So trying to program a robot to deal with all those little, variations, that would be a nightmare.
Exactly. And that's where diffusion policy comes in. It takes a completely different approach.
Okay, so tell me how it works. I'm all ears.
Well, think about it like you're sculpting with clay.
Yeah.
You start with this kind of rough shape.
Yeah.
And you gradually refine it, until you get the form you want.
Right.
Diffusion policy, it's doing something similar, but with actions.
Right.
It starts with this random, noisy action signal.
Okay.
And then it, progressively refines that signal based on what the robot's seeing.
Oh, so it's not like giving the robot super precise instructions. It's more like giving it a starting point and then letting it kind of figure out the best way to actually get to that goal on its own.
Exactly. And what's so cool is that this approach, it leads to some really amazing capabilities. One thing that diffusion policy is really good at is handling situations where there are multiple ways to do something correctly.
Oh, wow. That's huge, right?
Yeah.
Because that means robots could be way more flexible and adaptable in those real-world environments where, there isn't always one single right way to do things.
Exactly.
But, okay, so then how does it actually figure out which of those actions to take?
So it uses this really clever technique called receding horizon control.
Okay.
Think of it like you're driving to a destination.
Okay.
But you keep hitting detours and road closures.
Yeah.
You wouldn't just, blindly keep following your original plan, right?
Yeah.
You'd adjust your route based on what you're seeing, the latest information.
Right, of course.
So it's like the robot is constantly reassessing its plan and making these on-the-fly adjustments based on what it sees.
That makes a lot of sense. Now, I know the paper also mentions that diffusion policy is really good at predicting whole sequences of actions. So how does that work?
So think of it like learning a dance routine.
Okay, I like where this is going.
You don't just learn each step by itself. You learn the whole sequence.
Yeah, you got to get the flow.
Right, how one step leads into the next. So diffusion policy allows robots to do the same thing with actions. They learn to predict a series of actions into the future, which lets the robot move smoothly and efficiently.
That's like the robot is developing a sense of timing and coordination, almost like it's a dancer.
Exactly. And this is super important for tasks that require a specific order of operations, like assembling something.
Right.
Or, preparing a meal.
Okay, that makes a lot of sense. Now, we've talked a lot about how diffusion policy works in theory, but can you give us a specific example of how it's been used in practice?
Oh, for sure.
Yeah.
Researchers have used it to teach robots a whole bunch of things, like manipulating objects, navigating tricky environments. One example I think is pretty interesting. They used it to teach a robot to pour and spread sauce.
Ooh, that sounds tough.
It is. It needs a lot of control over the movements and an understanding of how the sauce will, flow and spread.
Yeah, totally.
But diffusion policy, it just nails tasks like this, because it can predict that whole sequence of actions needed to get the result, from tilting the bottle to spreading it all out evenly.
So it's not just about moving the robot's arm, it's about understanding the physics of it too, like how that sauce is going to behave.
Exactly. And that's, one of the things that makes diffusion policy so powerful. It lets robots learn and adapt to these complex real-world scenarios that would be really, really hard to program directly.
This is fascinating. It sounds like diffusion policy is a complete game changer for robotics. But I do want to dive a little deeper into the technical details of how it works. The paper mentions something called visual conditioning.
Right.
Can you explain what that is and why it matters?
Yeah. So visual conditioning, it's basically giving the diffusion policy system access to the robot's visual input, what it sees through its cameras.
Okay, but I mean, robots already have cameras, right?
I do, yeah.
So what's so special about this visual conditioning?
It's not just about having the cameras, it's about how you integrate that visual information into the diffusion policy framework.
Okay.
In the traditional way of doing things, you might use the visual input just to identify objects or estimate where the robot is.
Right.
But with visual conditioning, that visual input is directly used to shape how the robot acts.
Oh, so it's like the robot is using what it sees to actually guide its movements in real time?
Exactly. And that's super powerful because it allows the robot to react to these changes in the environment and adjust what it's doing accordingly.
That's incredible. It's like the robot's developing real hand-eye coordination.
Yeah, you could say that.
Okay, so visual conditioning helps the robot see and react to its environment. But what about the learning process itself? How does diffusion policy actually learn how to do these tasks?
Well, this is where things get really interesting. Diffusion policy uses this special type of neural network architecture. It's called a time series diffusion transformer to learn from data. And, transformers, they've been making a big splash in other areas of AI, like natural language processing.
I have heard of them, but I don't really understand how they work. Could you break it down for me?
Sure. Think of a transformer as this super-powered pattern recognizer.
Okay.
It's incredibly good at finding these relationships between different elements in a sequence of data.
Okay, so how does that apply to robots?
Well, a robot's movements and actions, they can be seen as this sequence of data over time, right? The robot does something, it sees what happens, it does something else, and so on. So this time series diffusion transformer, it can analyze that whole sequence and start to see those underlying patterns and relationships.
So it's like the robot is learning from its own experiences.
Exactly. And the more experience it gets, the better the transformer gets at, predicting what's going to happen.
So the transformer is basically helping the robot to plan its actions better.
Yeah.
But how does this diffusion part fit into all of this? I'm still not quite getting how that works.
Okay, let's go back to our sculpting analogy.
Okay, back to the clay.
Yeah. Imagine you're trying to sculpt this really delicate flower out of clay. You wouldn't just start by carving out every little petal in perfect detail, right?
Right.
You'd start with a rough shape and then, gradually refine it, adding more and more detail as you go.
So is the diffusion process gradually adding more detail to what the robot's doing?
Exactly. The time series diffusion transformer, it doesn't just predict a single action, it predicts a whole sequence of increasingly refined actions.
Okay.
Starting with a really rough, noisy guess.
Right.
And then getting more and more precise until it gets to, a well-defined action.
That's fascinating. It's like the robot is starting with a blurry picture of what it wants to do, and then it's slowly bringing that image into focus. But how does it know how to actually refine its actions? What's guiding this whole refinement process?
So that's where the visual feedback we were talking about earlier comes in. Remember, the robot's getting all this visual information about its surroundings.
Right.
The transformer uses that feedback to evaluate what it's predicting and make changes.
So it's like the robot is constantly checking its work.
Yeah.
And making corrections based on what it's seeing.
Precisely. And this continuous feedback loop, that's what allows diffusion policy to learn these complex, nuanced behaviors.
This is all so impressive. It sounds like diffusion policy is really pushing the limits of what we thought was possible in robot learning. But I'm sure there are still challenges and limitations to this approach. What are some of the areas where you think more research is needed?
You're absolutely right. There's always more to learn. One area where we need more research is making diffusion policy more efficient. Right now, it can take a lot of computing power to train these models, especially for complex tasks. So researchers are trying to make the algorithm faster and more efficient without, sacrificing performance.
So making it more accessible for robots that might not have a ton of processing power.
Exactly. Another thing researchers are working on is extending diffusion policy to even more complex tasks.
Hmm.
Right now, most of the work has focused on relatively simple things like, picking up objects or navigating basic environments.
Right.
But researchers are starting to explore how it can be used for more complicated things, like putting together furniture or preparing meals.
Oh, wow, that's exciting.
It is. It's like taking it from playing the piano to composing a symphony.
That's a great analogy.
Another exciting area is incorporating other senses beyond just vision. Currently, diffusion policy relies mainly on visual input, but robots can experience the world through a lot of senses, like touch, sound, maybe even smell.
So giving them a richer understanding of the world.
Exactly. Bringing those senses into diffusion policy. That could lead to even more robust robots, capable of handling a wider range of tasks and situations.
This has been a really insightful conversation. It seems like diffusion policy is truly groundbreaking.
It is.
And it has the potential to, really change how we think about robots and how we use them. Before we wrap up this part of our discussion, I'd like to ask, what's the most exciting thing about diffusion policy for you? What gets you most excited about this research?
What excites me the most is the potential to bridge the gap between, the kind of structured world of traditional robotics and the messy, unpredictable real world that we humans navigate so easily.
Oh, yeah.
For a long time, we've been trying to program robots with these really explicit rules and instructions, but the real world's just too complex for that to work perfectly.
So diffusion policy is like a way of teaching robots to deal with the real world on its own terms.
Exactly. Giving them the ability to learn from what they experience and adapt, that opens up so many possibilities for what robots can do and how they can interact with us. Imagine robots that can learn to do chores by watching us.
Yeah.
Or robots that could help surgeons with really delicate procedures, adjusting to each situation.
That's amazing. It's like we're giving robots the tools to become truly intelligent and independent.
Precisely. And that's what makes this research so compelling. We're not just building machines that follow orders, we're building machines that can learn, adapt, and work with us in ways we never thought possible.
This has been a really mind-blowing look into diffusion policy.
It is a fascinating area.
I feel like I've gotten a real glimpse into the future of robotics. But before we move on, I want to leave our listeners with a key takeaway.
Okay.
What's the one thing you want them to remember from this discussion?
I think the main takeaway is this. We're at the beginning of a whole new era in robotics, an era where robots aren't held back by our ability to program them. Diffusion policy and other approaches like it, they're giving robots the power to learn from their experiences, to adapt to how complex the world is, and that opens up a world of possibilities that we can barely imagine. I really believe that we're entering this incredible golden age of robotics.
Wow.
Where the line between science fiction and reality is going to get blurrier and blurrier.
It's a future full of amazing potential, but also some really big challenges.
It is.
But I think that if we're careful and thoughtful, and if we commit to using this technology responsibly, then we can really use the power of robot learning to make the world a better place for everyone.
I couldn't agree more. It's a really exciting time to be working in this field. The future is wide open.
Well, that's a fantastic note to end on. Thank you so much for joining us on this journey into the world of diffusion policy and the future of robot learning. It's been a real pleasure having you here.
It's been my pleasure.
And to all of our listeners out there, thank you for tuning in. Until next time, keep your minds open, your curiosity alive, and your robots learning.